Hey guys, this is Dr. B, and in this video I will show you how to use annihilators to find the general solution to a differential equation. So here goes. Find the general solution to y triple prime equals x. Okay, and the way we solve that is as follows. Let's start out by writing this differential equation in operator notation. So we have d3 of y equals x, and now we want to find an annihilator, so differential operator that makes this right-hand side 0. Now you can see here in the handout for annihilators that x to the power k gets annihilated by d to the power m, where m is greater than k. So in our case, we have x to the power 1. And so for this differential equation, any annihilator where the power of d is 2 or greater would work. So we're going to take the smallest annihilator that works, and that's d squared. So we're going to apply that annihilator to both sides of this differential equation, and we obtain the following. And because we use an annihilator on the right-hand side, we always get 0. And then on the left-hand side, d squared and d cubed, they together become d to the power of 5 differential operator, and that's of y. Okay, and now if we have the fifth derivative of y equals 0, when we look at the auxiliary equation, the corresponding auxiliary equation is r to the power of 5 equals 0. And the solutions to that, or the solution to that auxiliary equation, is r equals 0 with multiplicity 5. So all the solutions to this differential equation are e to the power 0x, then we have x e to the power 0x, then we have x squared e to the power 0x, and then x cubed e to the power 0x. That gives us 4 solutions. We need 5, so we get x to the power 4 e to the power 0x. Now all of these solutions, of course, can be simplified to 1x, x squared, x cubed, x to the power 4. And so our general solution so far will look as follows then. So it's y equals c naught times 1 plus c1 times x plus c2 times x squared plus c3x cubed plus c4x to the power 4. Okay, now if we look at the original differential equation and we leave off the x here and make that a 0, then we have y triple prime equals 0 being the homogeneous equation. And the solution to that part is this right here. So that's YH. And so the second part that we got through our Annihilator method, that is the particular part of our differential equation. And so for the particular part, if we're asked to find the general solution, these coefficients can be determined if initial values were given. But these are still undetermined coefficients that need to be determined based on the right-hand side. So what we need to do is we need to look at yp and its derivatives. So yp prime is 3c3 x to the power 2 plus 4c 4x cubed, and then yp double prime is 6c3 x plus 12c4x squared, and then yp triple prime, that is 6c3x plus 2 goes to the front, so that's 24c4x. Oops. I see I made a mistake there. So 24c4x. And of course, there's no x there anymore. So just remove that. And so yp triple prime is 6c3 plus 24c4x. And now let's compare that with the right-hand side. So if you compare that with, let's compare that with, how does that compare with x? Well, we can think of that as 1 times x plus 0. So here's the term with x, and so we see that 24c4, that's going to be 1, and then 6c3, that's our constant term, that will be 0. So our final answer for C3 and C4 will be C3 equals 0 and C4 equals 1 over 24. And our final answer then is y equals C0 plus C1x plus C2 x squared plus 1 over 24 x to the power 4.